Hello, and welcome to my Pre-Algebra review series. This video covers Chapter 7, Section 5, entitled Solving Equations with Variables on Both Sides. By the end of this video, you should have a better understanding of how to solve equations with variables on both sides, plus how to use equations with variables on both sides. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and certainly it'll help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. So let's do some math. Okay, so solving equations with variables on both sides. To solve an equation with the variable terms on each side or just on one side, use the addition property to collect the individual variable terms on one side and the constant terms on the other. If the variable and constant terms are enjoined via a distributive property, the enjoinment must be undone. So let's look at an example. Tanya got a 5% pay raise at her new job at the video store. She now makes $6.51 per hour. How much did she make per hour before the raise? Well, let's look at the pieces of this thing. So we have Tanya's pay, and we're going to call that P. Right here, Tanya's pay, calling it P, right there, P. And the new pay is $6.51, and her pay raise, well, was 0.5%. Okay, so let's write this in terms of an equation. So P is equal, her original pay P is equal to the new pay, $6.51, minus what the raise was, which was 5% of the original pay, which is minus 0.05P. Okay, right here, minus 0.05P. So once we've done this, we're going to now, we see the equation, we're going to have to undo the mathematics. And the mathematics here, it has to deal with the variable, because we really don't need to move the constant. It's already by itself on one side, and we have a P term on the other side of the equation, so we might as well move this P term here to the other side. So in order to do that, we're going to have to add what would be the inverse to this P term, which in this case is going to be plus 0.05p, because originally it was minus 0.05p. So we're going to add plus 0.05p on one side and plus 0.5p to the other side. Whatever you do on one side, you must do to the other. And also I'll remind you that 5% in decimal is 0.05. So once we've done that, we're going to simplify, and simplifying we'll get p plus 0.05 is equal to 1.05p, and the 0.05 on one side here is going to disappear because these two right here cancel themselves out. So now we have 1.05p equals 6.51. So now we have to undo the multiplication, and that's the 1.05 we have to get rid of. So to do that, we're going to divide each side. The 105p, we're going to divide it by, right here, 105, and this side by 1.05. You got to do the same on both sides. And when we do that, these two will cancel each other out, and we'll be left with p, right here, p. And 651 divided by 1.05 is 6.20. So Tanya originally earned $6.20 before her pay raise. So let's look at another example of collecting the variables on one side. So the problem says solve this. 9a plus 2 equals 4a minus 18. So in this problem we have constants on both sides and variable terms on both sides. So as I always like to say, rewrite the equation. You're probably going to be doing this on paper. The problem is probably in typewritten on your test. You're going to handwrite it on the paper, so you rewrite the problem and make sure you're starting with the correct problem, that everything is correct. So after you do that, you're going to have 9a plus 2 equals 4a minus 18. So from there, we'll go ahead and collect the constants. And I like to put them on the right side, but you can put them on either side. So in order to collect the constants, we're going to have to undo the subtraction or the addition. And we're going to undo that by subtracting from both sides. We're going to subtract this minus sign from both sides. The minus 2 from both sides. So minus 2 on one side over here, minus 2 on this side. These two are going to, when we simplify it, we're going to get rid of the 2's on this side and put the 2 on the right side. So we're going to have 9a equals 4a minus 20, because we had minus 18 and minus 2 is minus 20. That's simplifying the constants. Now we're going to work on the variable terms. So we have a minus 4a, a 4a on the right side, and we need to put a minus 4a in here to get rid of that minus 4a, to get rid of the 4a and move it over to the left-hand side. So 9a minus 4a is equal to 4a minus 4a, 4a minus 4a, plus, minus 20. So when we work this out, we're going to get 5a. So 9a minus 4a is 5a, right here, 5a. And we're going to be left with the minus 20, because the 4a's right here canceled each other out. So now we have 5a equals minus 20. So we have to undo the multiplication. And that's to get rid of the 5, because we have to have the a by itself. So in order to do that, we're going to multiply by the reciprocal, or the multiplicative inverse. The reciprocal of 5 is 1 over 5. As we see right down here, 1 over 5, right here. Okay, so we're going to divide 5a by 5, and we're also going to divide minus 20 by 5. Here's the 5s we're going to divide by on both sides. When we do that, the 5s will cancel, and we're going to be left with 1a. 5 over 5 is 1. So 1a is equal to minus 4, because minus 20 divided by 5 is equal to 4. So let's check it, see if it worked. We'll put a minus 4 everywhere the a showed up in the original equation. So it was 9 times minus 4 plus 2 is equal to 4 minus 4 minus 18. Well, 9 times minus 4 is minus 36, plus 2 is minus 34. And on the other side, we have 4 times minus 4 is minus 16, minus 18, and minus 16 and minus 18 is minus 34. So as it shows here, it checks. So let's work on a couple problems. Let's see how they turn out. Just to solve and check. So A says 4x plus 4 is equal to 2x plus 36. Well, let's bring the 4 over here to the right-hand side. The 4 come over here. Let's do that. So we're going to have 4x. In order to get rid of that 4, we have to have plus 4 and a minus 4. We have to subtract, plus 4 and a minus 4. We have to subtract the 4 from this side. And if we subtract it from the one side, we got to subtract it from the other. So we have 2x plus 36. And we're subtracting 4 minus 4. So if we simplify this, we're going to get 4x, the 4's cancel, is equal to 2x. We haven't done anything with the 2x yet. 36 minus 4 is equal to 32. So now we have to get rid of the x from the right-hand side with the constant to get it over to the other side with the variable terms. In order to do that, we're going to subtract the variable term, 2x, from both sides. So we're going to have 4x minus 2x is equal to 2x minus 2x plus 32. Okay, now we simplify. And simplifying, these are going to disappear. They're going to cancel themselves out. And the 4x minus 2x will leave us with 2x. And that 2x is going to be equal to 32. And now we have to get rid of the 2 by undoing the multiplication and ending up with a single x variable. So in order to do that, we're going to divide each side, or multiply. Let's do this. We're going to multiply each side by 2. 1 half times 2 32 times 1/2. That's the reciprocal of 2. And these 2's cancel. And then you end up with that 1 right there, 1x. So equals to x equals, and 32 divided by 2 is 16. So if we put it back in, what do we get for a solution? So if we say 4 times, 4 times 16 plus 4 equals 2 times 16 plus 36. Well, let's see what this comes out to. So 2 times 16 is what? 64 plus 4 is equal to 32 plus 36. Well, 64 plus 4 is 68, and 32 plus 36 is 32 plus 32 is 64, plus 4 is 36, so it's 68. So bingo, that checks. Let's do the other one, problem B. So we have minus 15 plus 6b, and then we have minus 8b plus 13. And as usual, we're going to move the constants around and the variables around to get the variables on the left side, and I'll put the constants on the right side. So the first thing we're going to do is we're going to start by moving the constants. So I'm going to add 15 minus 15 plus 6b is equal to minus 8b plus 13 and plus 15. Plus 15. So if we do this, the 15, this is going to disappear. The plus 15 and the minus 15, they're going to disappear. And we're going to end up with a 6b. And that's going to be equal to minus 8b plus 15 and 13. 15 and 15 is 30. Minus 2 is 28. 28. So now we've got this minus 8b over here. So I had minus 8, minus 8, correct? So we have to get the minus 8 to the other side. So we're going to say 6b plus 8b is equal to minus 8b plus 8b plus 28. So now that we've done that, we're going to see that the 8b's here cancel. So we're going to have 6b plus 8b is going to be 14b is equal to 28. And b is going to be equal to, well, I'll do this. I'll say we're going to multiply by the reciprocal of 14. So 1 over 14 times 14b is equal to 28 times 1 over 14. And therefore these cancel, and b equals 28 divided by 14 is equal to 2. And if we put a 2 in here, minus 15 plus 6 times 2, so minus 15 plus 6 times 2 is equal to minus 8 times 2, minus 8 times 2 plus 13. So what does this go to? So here we've got a minus 15, and this is 2 times 6. So that's going to be 12. So minus 15 plus 12 is equal to minus, here's the minus sign, minus 16 plus 13. So minus 15 plus 12 is minus 3. And minus 16 plus 13 is minus 3. So both sides are check. So in objective 2 is we're going to be using equations with variables on both sides. We've kind of been doing that. But what we're going to find new here is that we're going to be using the distributive property to simplify one or both sides of an equation before we can get around to the variables on one side and the constants on the other. We have to unenjoin these enjoined terms, the variables and constants with the parentheses. So that's what we're trying to get rid of. So if we start off, if we look at it, we're going to start off by saying that we have 4 times 8 minus y the quantity 8 minus y, is equal to 2 times the quantity y plus 8. So the first thing we have to do is we have to take and multiply the 4 times the 8 and get 32, and the 4 times the minus y and get minus 4y right here. So now these are disjoined, I guess. I don't know what the word for that is. Anyways, we've separated these, okay? Unenjoined. So now on this side, the other side, we have 2 times y, 2y, and we have 2 times 8, which is 16. So now everything is, we've removed the parentheses and got rid of anything to do with the distributive property in this one step. Okay? So now this is just like every other problem we've had. We're going to take and we're going to remove the 16 from this side of the equation right here and bring it over to the other side, to the left hand. Or is that what we're doing? Oh yeah, we're putting them backwards. See down here at the bottom, they're backwards. So that's what we're going to do. We're going to move the 16 over here to the left-hand side, and the variable term is going to go to the right-hand side. It's a little mix-up from what we've been doing on the other problems. So in order to do that, we're going to subtract 16 from the right-hand side. So we have 2y plus 16 minus 16. And then we're going to, on the left-hand side, we have 32 minus 16 minus 4y. Okay, so now we're going to simplify. So we're going to get minus 16. So 32 minus 16 is 16. And then we have the 4 minus 4y. And on the right-hand side, we have 2y right here, 2y. And the 16s cancel. So we're left with 2y right here. Okay, so now we have to get the y's by themselves, and that means we have to take the minus 4y and move it to the right-hand side. And the way that we do that is we have to add a plus 4y. We have to add the opposite. Minus 4y gets a plus 4y. So we're ended up with what? The 16, right here's a 16, and a minus 4y and a plus 4y. That'll be getting rid of the 4y, minus 4y. And we have to add a plus 4y to the right-hand side because whatever you do on one side, you have to do on the other side. There's the plus 4y on this side from the plus 4y over here. When you simplify it, you're going to get the 16 remaining on one side. These will cancel. And this side, you're going to have a 2y plus a 4y, and that's going to give you a 6y. So 16 equals 6y. So what does y equal? We have to get rid of the 6. So we're going to divide both sides by 6. So 6 divided by 6y equals y. And 16 divided by 6 equals 2 and 2/3. 6 goes into 16 2 times. That's 12, 2 6s, and 4 left over. And 4/6 is 2/3. So y equals 2 and 2/3. Okay, so we have a real-world problem as an example here. It says Beth leaves home on her bicycle, riding at a steady rate of 8 miles per hour. Right here, 8 miles per hour. Her brother Ted leaves home on his bicycle 1/2 hour later, following Beth's same route. Okay, and it says here that it's 1/2 hour later, 1/2 hour later, right here, later. Okay, so it says he rides at a steady rate of 12 miles per hour. So Beth is going 8 miles an hour, and Ted's going 12 miles per hour. How long after Beth leaves will Ted catch up? They're riding in the same direction. Eventually, Ted's going faster, so if they drive long enough, Ted will catch her. And he will catch her when what? When Ted catches Beth, their distances will be equal. Because they're both going in the same direction. When he catches, they'll finally be exactly the same. The distance. Different amount of time for him to travel with her because he's going faster, but they'll go the same distance. Beth's distance equals Ted's distance right here. Beth's distance equals Ted's distance. So what could the equation be? Well, we could say that 8 miles per hour, which is Beth, times the time she's driving or pedaling is X. We don't know how much time that is, but it's some value that we're looking for, actually. We want to know what her time was, we can also know then what Ted's time was. Okay? So, and that they're wanting to know how fast will it catch up. So then, and Ted's going to be 12 miles per hour times his time. Well, what is his time? His time is whatever her time is, x, minus a half an hour, because he left a half hour later. So he's going to travel Beth's time minus a half an hour. Okay? So when we write this into an equation form, we're going to get 8x, which is 8 times x, Beth's time, x, is equal to 12 times the quantity. Because what is the quantity? Well, it's x minus the half hour. That's what his quantity is. So it's got those two terms in there. Because his time is based on her time. Her time, he's a half an hour later than her. So he's going to be going 12 miles an hour times x minus 1/2 hours. Okay? So when we solve this now, we're going to see 8x is equal to 12 here. 12 times the quantity x minus 1/2. So this is rewriting the equation to make sure we have it's right. Okay? So now we're going to play with this. So 8x is equal to 12x. Right here, when you do 12 times x, you get 12x. And when you do 12 times a half, you're going to get minus 6. Minus a half times 12, minus 6. Okay, we just undid the distributive property. So now that that's undone, we can collect terms. Because we've created some terms on the right side that we need to move one. And the one we're going to move happens to be the 12x. Because we want that on the left side. So now that we've got the new equation, we can say minus 12x, because we want to take the 12x from the right-hand side, put it on the left, plus 8x, here's the 8x that's already there, is equal to 12x, where we're starting, minus the 12x that we want to use to remove and undo the 12 on this side and put it on the other side, minus 6. So minus 12x plus 8x is equal to 12x minus 12x minus 6. So the 12 and the minus 12 cancels. And you're going to get, and over here you're going to add the minus 12 and 8 together, and you're going to get minus 4x. So minus 4x is equal to minus 6. So now to undo the division here with the 8 on the x, we have to get it a single x, 1x. What we have to do is we have to divide by, not the 8, the 4. We have to divide we have to get rid of the 4x, minus 4x. We have to divide the minus 4 by minus 4. That way we'll get rid of the negative sign and the 4 at the same time, times x. And we do the same thing on both sides, so we're going to take the minus 6 and we're going to divide it by minus 4. And when we do that, the minuses and the 4s will disappear, and it'll be just an x on this side. And what's left over is going to be the minus signs cancel each other out. A minus divided by minus is a positive. And 6 divided by 4 is 1 1/2. Okay? So that's simplified, 1.5 hours. So they will travel, x will be Beth's time on the road, 1.5 hours. And according to this equation, Ted, he left a half hour later, so he's going to be traveling 1 hour, and she's going to be traveling for 1.5 hours, and they'll go the same distance. Oh, and I hope you caught that where I said the minus 8, and excuse me, I meant to go back when I was talking about the minus 8, the minus 4. I said earlier, I said the 8 had to be undone when I jumped back too far. Sorry about that. Okay, now we're going to check our understanding. So car A leaves East Town traveling at a steady rate of 50 miles an hour. Car B leaves East Town 1 hour later, following car A, and it travels at the steady rate of 60 miles per hour. How long after car A leaves East Town will car B catch up? So in other words, how long will car A be driving when B finally catches it? And this is very much like the Ted and his sister's problem, except that we're using cars and different speeds, basically. And the time travel, or the time leaving, is instead of a half an hour, is an hour. So we have 50 miles per hour, right here, 50 miles per hour, and is equal to 60 miles an hour times, here's this distributive property where we had x minus a half in the previous problem. Here we have h, which is any variable we want to use, we can do that. And here it's for hours, I guess. So h is hours. And h minus 1, because car B is going to be traveling 1 hour less than car A. So if we solve this, we're going to have 50 miles per hour times h is equal to 60 miles per hour times h. That's an h, not a b, minus 60. Because minus 1 times 60 is minus 60. Okay, so now we have, let's see, we're going to take, so now we have it needs to be moving the variable term to the opposite side to get them together. So we'll end up with 50, I'm not going to write the miles per hour, 50 h minus 60 h is equal to, now this side is going to be 60h minus 60h minus 60. Okay, so now we've simplified this. 50 minus 60 is minus 10h is equal to 60 minus 60 is 0 and equals minus 60. Okay, so now we have a negative on this side and 10. So we have to get rid of the negative 10. So h is going to be equal to negative 10 divided by negative 10 times h is going to be equal to minus 60 times 1 over minus 10, the reciprocal of 10. So h is going to be equal to, the 10's divided into here, and you'll end up with 6, because the minuses cancel. 6 divided by 10 is 60 divided by 10 is 6. So h is 6. So car A is going to travel for 6 hours, and B is going to travel for 5 hours. Okay, so now we can do a few exercises. I think we have 4 to do here, so let's start off with these first couple and the exercises. So exercise number 1 says 2x, 2 times the quantity x minus 4 equals 3x. So let's run this out here. So 2x, 2 times x minus 4 is equal to 3x. Okay, so we're going to multiply out the distributive property part of the problem. So 2 times x is 2x, minus 2 times minus 4 is minus 8, and that equals 3x. So we have to move the minus 8, or we can leave it here, and we're going to take the 3x and move it down to the left side. Almost doesn't matter. But one's 2 steps and the other one is 1 step. So let's move the 2x to the right side of the problem. So to do that, we're going to say 2x minus 2x minus 8 equals 3x minus 2x minus 2x. Okay, so to simplify this, we have these 2 cancel. We have minus 8 equals 3x minus 2x is x. So x equals minus 8. How about the next one? 1/2 times the quantity 4d minus 2 is equal to d plus 5. So the quantity 4d minus 2 has to be unentangled, so to speak. So we're going to multiply both terms inside there by a half. So 1/2 times 4d, okay, times 4d minus 1/2 times 2 minus, I got the minus in here, 2. Okay, so, and that equals d plus 5. So 1/2 times 4d is 2d, and minus a half times 2, or a half times minus 2, is equal to minus 1, and that equals d plus 5. Okay, so now what do we want to do? I guess we're going to move both terms. We have to move the minus 1 and possibly the d, I guess. So let's do that. We'll bring the d to the left side. So we're going to have 2d minus d minus 1 is equal to d minus d plus 5. Okay, so now we've just taken care of the d terms. And if we simplify that, we're going to have 1d, 2d minus 1d, 2d minus 1d is equal to d minus 1 is equal to, the d's cancel and you end up left with plus 5. Okay, so now that we have that, we're going to move the minus 1 to the other side of the equation to clear the d by itself. So now we're going to have d minus 1 plus 1 equals 5 plus 1. Whatever you do on one side, you have to do it to the other side. So now we have d equals, because these ones cancel, 5 plus 1 is 6. Boom. D equals 6. Okay, for the last two problems in our exercises here. Problem 3. A jet leaves an airport traveling at a steady rate of 600 kilometers an hour, and another jet leaves the same airport 3/4 of an hour later and traveling at 800 kilometers per hour in the same direction. How long will it take for the second jet to catch the first? So we're trying to find the time here. So we're going to make our variable t. So we're going to start off with 600 kilometers km per hour times t, okay, is equal to 800 km divided by h times the quantity of what? Well, the time that the first plane left minus 3/4. That's to define this plane's time, because he's flying the amount of this plane's flying minus 3/4. That's what he'll be flying when he catches them. He'll be flying 3/4 of an hour less than the other plane was flying. So now when we extend this, we have 600 km per hour times t. I could say t hours. How's that? Equals 800 km per hour times x minus 800 km that's it. Okay, so it's we've undone the distributive property. 800 times x, 800 km hours per x, and 800 km per hour minus 3/4. Minus times minus 3/4. Okay, so now that problem has written itself out here. So now we're going to get 600. I'm going to get rid of the letters because it's starting to look a little messy here. 600 times t is equal to 800 x minus 800 times 3/4. Okay, so the x term can come to this other side, and we can solve this mathematical problem right here as it is. So moving the 800, let's solve this part first. Let's solve the 800 times 3/4. 600t minus equals 800t. I put x. Sorry. Okay, t minus 800 divided by 4 is 200, times 3 is 600, minus 600. Okay, so now we can move the 800. We have minus 800 t plus 600 t is equal to 800 t minus 800 t minus 600. So this is where we subtracted out the 800 from that was up in here, the 800t. So these two cancel. And on this side, minus 800t plus 600t is minus 200t. And that's equal to minus 600. And then if we divide both sides by minus 200 to get rid of the negative 200 on this side, dividing by minus 200 on each side, minus 200, t will equal to 3. T equals 3 because 200 goes into 600 3 times. Okay, and finally the last problem. This is going to be this will be interesting because we have to look at what the words are saying. It's not a tough problem, but just to help you get used to the words. So it says if a number n, so we have some unknown number n, is subtracted from 18. Oh, so you're going to take 18 and you're going to subtract n from it. Well, let's write that. 18 minus n. The result is, equals. The result is in this case means equals. So if you subtract n from 18, your answer is going to be 4 less than n. Oh, it's going to be n minus 4. Okay? Not too bad. So now we have to collect like terms. So if we collect them, we have 18 on this side and minus 4 on this side. So we can bring the minus 4 over to the left-hand side. So we're going to have 18 and plus 4 minus n is equal to n minus 4 plus 4. There's the plus 4 from both sides to get rid of the minus 4 right here. These cancel, and you're going to have 18 plus 4 is 22 minus h, or n rather, sorry, minus n is equal to n. Okay, my n's are looking like h's. Sorry about that. So now we have to get rid of the n from this side. So we're going to have 22 minus n plus n is equal to n plus n. So when we get rid of those n's, we're going to have 22 is equal to 2n. And now we have to resolve that. We have to undo the multiplication here. To get rid of this, we're going to divide both sides by 2 or multiply by the reciprocal. Let's multiply by the reciprocal. So it's the reciprocal of 2 is 1 over 2 times 22 is equal to 1 over 2 times 2n. And this cancels this, leaving us with an n. And 1/2 of 22 is 11. So the answer is n equals 11. Okay? Thank you.